to the Docker Hub and find, for example, a Redis image. Another thing is that Docker Hub, all the artifacts that are in the Docker Hub are images. So we're not talking about containers here. All of these things are images, Docker official image. So we're going to go ahead and pull a Redis image out of the Docker Hub to my laptop. So you see the different layers of the image are downloaded. And this will take a couple of minutes. So once the download is complete, I can check all the existing images on my laptop using Docker images command. So I see I have two images, Redis and Postgres, with tags, image IDs, and so on. Another important aspect of images is that they have tags or versions. So for example, if we go back to the Docker Hub, each image that you look up in the Docker Hub will have many different versions. The latest is always the one that you get when you don't specify the version, of course. If you have a dependency on a specific version, you can actually choose the version you want and specify it. And you can select one from here. So this is what you see here. The tag is basically the version of the image. So I just downloaded the latest, and I can also see the size of the image. So now to this point, we have only worked with images. There is no container involved, and there's no Redis running. So now if, let's say I need Redis running so that my application can connect to it, I'll have to create a container of that Redis image that will make it possible to connect to the Redis application. And I can do it by running the Redis image. So if I say docker run Redis, this will actually start the image in a container. So as I said before, container is a running environment of an image. So now if I open a new tab and do docker ps, I will get status of all the running Docker containers. So I can see the container Redis is running with a container ID based on the image of Redis and some other information about it. For example, the port that it's running on and so on. So as you see here, the docker run Redis command will start the Redis container in the terminal in an attached mode. So for example, if I were to terminate this with the Control C, you see that Redis application stops and the container will be stopped as well. So if I do docker ps again, I see that no container is running. So there is an option for docker run command that makes it possible to run the container in a detached mode, and that is -d. So if I do docker run -d Redis, I will just get the ID of the container as an output, and the container will stop running. So if we check again docker ps, I see the container with the ID starting with 838, which is the same thing here, is running. So this is how you can start it in a detached mode. Now, for example, if you would want to restart a container because, I don't know, the application crashed inside or some error happened, so you want to restart it, you would need the container ID. So just the first part of it, not the whole string. And you can simply say docker stop ID of the container, and that will stop the Docker container. Nothing running. If you want to start it again, you can use the same ID to start again. So let's say you stop Docker container. At the end of the day, you go home, you come back the next day, open your laptop, and you want to restart the stopped container, right? So if you do docker ps, the output is empty, you don't see any containers. So what you can do, alternative to just looking up your history, command line history, is you can do docker ps -a, which will show you all the containers which are running or not running. So here you see the container ID again, and you can restart it. Okay, so let's try another thing. Let's say you have two parallel applications that both use Redis, but in different versions. So you would need two Redis containers with different image versions running on your laptop, right? At different times maybe, or at the same time. So here we have the latest one, which is Redis 5.06. And let's head over to the Docker Hub and select version. Let's say you need version 4.0. So remember the first time that we downloaded the Redis image, we did docker pull Redis. However, if you use docker run with Redis image and the tag, which was 4.0, it will pull the image and start the container right away after it. So it does two commands basically in one. So it's docker pull, then docker start in one command. So if I do this, it says it can't find the image locally, so it goes and pulls the image from the repository to my laptop. And again, we see some layers are downloaded and the container is started right away. And now if I do docker ps, you see that I have 2 Redises running. So this is where it gets interesting. Now, how do you actually use any container that you just started? So in this output, you also see the ports section, which specifies on which port the container is listening to the incoming request. So both containers open the same port, which is what was specified in the image. So in the logs of the container, you can see the information, running mode, standalone port 6379. So how does that actually work? And how do we not have conflicts while both are running on the same port? So to explain that, let's head over to our slide and see how this works. As you know, container is just a virtual environment running on your host. And you can have multiple containers running simultaneously on your host, which is your laptop, PC, whatever you're working on. And your laptop has certain ports available that you can open for certain applications. So how it works is that you need to create a so-called binding between a port that your laptop, your host machine has, and the container. So for example, in the first container part here, you see container is listening on port 5000 and you bind your laptop's port 5000 to that containers. Now, you will have conflict if you open 2 5000 ports on your host, because you will get a message, the port is already bound or is already in use. You can't do that. However, you can have 2 containers, as you see, the second and third containers are both listening on port 3000, which is absolutely okay as long as you bind them to 2 different ports from your host machine. So once the port binding between the host and the container is already done, you can actually connect to the running container using the port of the host. So in this example URI, you would have some app, localhost, and then the port of the host. And the host then will know how to forward the request to the container using the port binding. So if we head back, here you see that containers have their ports and they're both running on the same one. However, we haven't made any binding between my laptop's port and the container port. And because of that, the container is basically unreachable by any application, so I won't be able to use it. So the way we actually do that is by specifying the binding of the ports during the run command. So I'm gonna break this and check that there is just one container running now. I'm gonna stop the other one as well so we can start them anew. Okay, so we see both containers are here. So now we want to start them using the binding between the host and the container ports. But again, we have 2 Redises, so we need to bind them to 2 different ports on my laptop. So the way to do it is you do docker run and you specify with -p the port of the host. That's the first one. So let's go with 6000. It doesn't really matter in this case. And the second one is the port that you're binding this to, which is the container port. So we know the container port will be 6379, and this is where we bind my laptop's port 6002. And if I do this, I forgot to raise here. So, and now if I do docker ps, let's actually clean this, docker ps again. Here you see the binding here, right? So your laptop's 6000 port is bound to the containers 6379. So now let's do another thing and let's start it in a detached mode. So like this. Let's check again. It's running again. And now I want to start the second container. Let's clear this again. So here you see it created a bunch of containers because when I specified different options with the port binding, it actually created new containers. That's why you see a couple or more here. So I'm gonna copy the image name with the tag for .o -p. So for example, if I were to do this now, and I would try to run the other Redis, the second Redis container with the same port on my laptop, I would get an error saying the port is already allocated. So I can do 6001 and run it. Again, I'll run it in detached mode so that I don't see the port. And if I go over here and say docker ps, I see that I have two different Redis versions running, both of them bound to different ports on my laptop, and the containers themselves listening to requests on the same port. So far we have seen a couple of basic Docker commands. We have seen docker pull, which pulls the image from the repository to local environment. We also saw run, which basically combines docker pull and docker start, pulls the image if it's not locally available and then starts it right away. Then we saw docker start and docker stop, which makes it possible to restart a container if you made some changes and you want to create a new version, which makes it possible to restart a container if you need to. We also saw docker run with options. The one option that we saw was -d, which is detach. So you can run the container in detached mode, so you can use terminal again. -p allows you to bind port of your host to the container. So very important to remember -p, then comes the port of your host, and then comes the port of your container, whatever it might be. We also saw docker ps -a, which basically gives you all the containers, no matter if they're running currently or not. We also saw docker images, which gives you all the images that you have locally. So for example, if after a couple of months you decide to clean up your space and get rid of some stale images, you can actually check them, check the list, and then go through them and delete them. You can do the same with stale Docker containers that you don't use anymore or you don't need anymore. You can also get rid of them. So the final part of the Docker basic commands are commands for troubleshooting, which are very, very useful. If something goes wrong in the container, you want to see the logs of the container, or you want to actually get inside of container, get the terminal, and execute some commands on it. So let's see docker ps. We have two containers running, right? Now, we don't have any output. We don't see any logs here. So let's say something happens. Your application cannot connect to Redis, and you don't know what's happening. So ideally, you would want to see what logs Redis container is producing, right? The way to do that is very easy. You just say docker logs and you specify the container ID and you see the logs. You can also do the docker logs if you don't want to remember the container ID or do docker ps all the time. You can remember the name of the container and you can get the logs using the name. So a little side note here, as we're talking about the names of the containers. So here, as you see, when a container is created, you just get some random name like this. So you can name your containers as you want using another option of the Docker run, which might be pretty useful sometimes if you don't want to work with the container IDs and you just want to remember the names, or if you just want to differentiate between the containers. So for example, let's create a new container from Redis 4.0 image using a different name that we choose. So I'm going to stop this container. And I'm going to create a new one from the same image. So let's run it in the detached mode. Let's open the port 1001.2.6.3.7.9 and give the name to the container. And let's call, since it's the older version, let's call it Redis older. And we need to specify the image. So remember, this will create a new container since we're running the docker run command again. So if we execute this and check again, we see the Redis 4.0 image based container is created, which is fresh new. You can see it created, and the name is Redis older. And we can do the same for the other container so that we kind of know which container is what. So I'll stop this one. And I will use the same command here. This will be the latest, and I will call this Redis latest. And since bind another port, so I'm gonna run it and let's see. So here I have two containers running. Now I know Redis older, Redis latest. So for example, if the older version has some problems, I can just do logs Redis older and I can get my logs. So another very useful command in debugging is docker exec. So what we can do with docker exec is we can actually get the terminal of a running container. So let's check again. We have two containers running, and let's say there is some problem with the latest Redis latest container, and I want to get a terminal of the container and to maybe navigate a directory inside, check the log file, or maybe check the configuration file, or print out the environmental variables, whatever. So in order to do that, we use docker exec command with -t, which stands for interactive terminal. Then I specify the container ID and I say bash. So I get the bash. And here you see that the cursor changed So I'm inside of the container as a root user. And here, if I say ls, okay, the data is empty, I can also print out in which directory I am. I can go to the home directory, see what's there. So I have my virtual file system inside of a container. And here I can navigate the different directories and I can check stuff. I can also print all the environmental variables to see that something is set correctly and do all kinds of stuff here. And this could be really useful if you have a container with some complex configuration, or if, for example, you are running your own application that you wrote in a container and you have some complex configuration there or some kind of setup, and you want to validate that everything is correctly set. In order to exit the terminal, you just do exit and you're out. You can also do the same using the name. Again, if you don't want to work with the IDs and you just want to remember the names of the container to make it easier, you can do it with the name as well. Same thing. Since most of the container images are based on some lightweight Linux distributions, you wouldn't have much of the Linux commands or applications installed here. For example, you wouldn't have curl or some other stuff. So you're a little bit more limited in that sense. So you can execute a lot of stuff from the Docker containers. For most of the debugging work, it should be actually enough. So the final part to review the difference between Docker Run and Docker Start, which might be confusing for some people. Let's revisit them. So basically Docker Run is where you create a new container from an image. So Docker Run will take an image with a specific version or just latest, right, as option or as an attribute. With Docker Start, you're not working with images, but rather with containers. So for example, as we saw, Docker Run has a lot of options. You specify with -d and -p, the port binding, and then you have this name of the container and all this stuff. So basically you tell Docker at the beginning what kind of container with what attributes, name, and so on to create from a specific image. But once the container is created, and you can see that using the command. So for example, here, the last ones that we created. And if you stop it and you want to restart it, you just need to use the command docker start and specify the container ID. And when you start it, the container will retain all the attributes that we defined when creating the container using Docker Run. So Docker Run is to create a new container. Docker Start is to restart a stopped container. So once you've learned the Docker basic concepts and understood how it works, it's important to see how Docker is actually used in practice. So in software development workflow, you will know you have these classical steps of development and continuous delivery or continuous integration, and then eventually it gets deployed on some environment, right? It could be a test environment, develop environment. So it's important to see how Docker actually integrates in all those steps. So in the next couple of videos, I'm going to concentrate exactly on that. So we're going to see some overview of the flow, and then we're going to zoom in on different parts and see how Docker is actually used in those individual steps. So let's consider a simplified scenario where you are developing a JavaScript application on your laptop, right? On your local development environment. Your JavaScript application uses a MongoDB database, and instead of installing it on your laptop, you download a Docker container from the Docker Hub. So you connect your JavaScript application with the MongoDB and you start developing. So now let's say you develop the application, first version of the application locally, and now you want to test it, or you want to deploy it on the development environment where a tester in your team is going to test it. So you commit your JavaScript application in Git or in some other version control system. That will trigger a continuous integration, a Jenkins build, or whatever you have configured. And Jenkins build will produce artifacts from your application. So first, it will build your JavaScript application and then create a Docker image out of that JavaScript artifact, right? So what happens to this Docker image once it gets created by a Jenkins build? It gets pushed to a private Docker repository. So usually in a company, you would have a private repository because you don't want other people to have access to your images. So you push it there. And now, as a next step, could be configured on Jenkins or some other scripts or tools. That Docker image has to be deployed on a development server. So you have a development server that pulls the image from the private repository, your JavaScript application image, and then pulls the MongoDB that your JavaScript application depends on from a Docker Hub. And now you have two containers, one your custom container and a publicly available MongoDB container running on dev server. And they talk to each other. You have to configure it, of course. They talk and communicate to each other and run as an app. So now if a tester, for example, or another developer logs in to a dev server, they will be able to test the application. So this is a simplified workflow, how Docker will work in a real-life development process. In the next videos, I'm going to show you a hands-on demo of how to actually do all of this in practice. So in this video, we are going to look at some practical example of how to use Docker in a local development process. So what we're going to do is a simple demo of a JavaScript and Node.js application in the backend to simulate the local development process, and then we're going to connect it to a Docker container with a MongoDB database in it. So let's get started. So in this video, we're going to see how to work with Docker containers when developing applications. So the first step will be we're going to develop a very simple UI backend application using JavaScript, very simple HTML structure and Node.js in the backend. And in order to integrate all of this in the database, we are going to use a Docker container of a MongoDB database, and also to make working with the MongoDB much easier so we don't have to execute commands in the terminal, we're going to deploy a Docker container of a Mongo UI, which is called the Mongo Express, where we can see the database structure and all the updates that our application is making in the database. So this development setup should give you an idea of how Docker containers are actually used in the development process. So I've already prepared some very simple JavaScript application. So in order to see the code, basically we have this index.html that is very simple code, and we have some JavaScript here, and we're using Node.js backend that just serves that index.html file and listens on port 3000. So we have the server running here in the backend, and we have the UI that looks like this. So basically it's just a user profile page with some user information, and user can edit their profile. So if I, for example, change the name here, and if I change the email address and do changes like this, I can save my profile and I have my updates here. However, if I refresh the page, of course, the changes will be lost because it's just JavaScript Node.js. So there is no persistent component in this application. So in order to have that, which is actually how real life applications work, you'll know that you need to integrate the application with a database. So using that example, I will try to showcase you how you can actually use the Docker containers to make the development process easier by just pulling one of the databases and attaching it or connecting it to the application. So in this case, we're going to go with the MongoDB application. And in addition to MongoDB container, we're going to also deploy a MongoDB UI, which is its own container. It's called Mongo Express, where we can manage or see the database insights and updates from our application much easier. So now let's see how that all works. So in order to get started, let's go to Docker Hub and find our MongoDB image. So here, let's go to Mongo. And we have MongoDB here. And the Mongo Express, which is another Docker container that we're going to use for the UI. So first, let's pull the MongoDB official image. So I already have MongoDB latest, so pulling doesn't take longer on my laptop, but you're going to need a couple of seconds probably. And the next one we're going to pull is the Docker Express, which I also have, I believe. So let's see. Yes, it's also fast. So if I check locally, I have MongoDB and Mongo Express images. So the next step is to run both Mongo and Mongo Express containers in order to make the MongoDB database available for our application, and also to connect the Mongo Express with the MongoDB container. So let's do the connection between those two first. In order to do that, we have to understand another Docker concept, Docker network. So how it works is that Docker creates its isolated Docker network where the containers are running in. So when I deploy two containers in the same Docker network, in this case Mongo and Mongo Express, they can talk to each other using just the container name, without localhost, port number, etc., just the container name, because they're in the same network. And the applications that run outside of Docker, like our Node.js, which just runs from Node server, is going to connect to them from outside or from the host using localhost and the port number. So later, when we package our application into its own Docker image, what we're going to have is, again, a Docker network with MongoDB container, Mongo Express container, and we're going to have a Node.js application, which we wrote, including the index.html and JavaScript for frontend in its own Docker container, and it's going to connect to the MongoDB. And the browser, which is running on the host, but outside the Docker network, is going to connect to our JavaScript application, again, using hostname and the port number. So Docker by default already provides some networks. So if we say Docker network ls, we can already see these auto-generated Docker networks. So we have 4 of them with different names, and the drivers, we're not going to go into details here, but what we're going to do is create its own network for the MongoDB and the Mongo Express, and we're going to call it Mongo Network. So let's do this right away. I'm going to say Docker Network create, and we are going to call it Mongo Network. So now if I do Docker Network ls again, I see my Docker network has been created. So now in order to make our MongoDB container and the Mongo Express container run in this Mongo network, we have to provide this network option when we run the container in the Docker run command. So let's start with the Mongo. So we all know that Docker run is the command to start a container from an image, right? So we have Docker run Mongo, which is the basic Docker run command. However, in this case, we want to specify a couple of things. As you learned from the previous videos, you have to specify something called port. So we need to open a port of MongoDB. The default port of MongoDB is 27017. So we'll take that port actually for both host and container. So Mongo will run at this port inside of a container, and we open the same port on the host. So that will take care of the port. Then we will run it in a detached mode. In addition to that, there are a couple of things that we can specify when starting up the container. And these are environmental variables of the MongoDB. Let's see, in the official image description, you actually have a couple of documentation about how to use the image, which is very helpful to kind of understand what kind of configuration you can apply to it. Here you see some environmental variables. So basically on startup, you can define what the root username and the password will be, which is very handy because we're going to need those two for the Express to connect to the Mongo. And you can also specify the init database. We're just going to provide the username and password because we can create the database from the Mongo Express UI later. So let's do that. And the way you can specify the environmental variables, you can actually see here as well, is by just, let's copy this one. So here, you say environmental variable, that's what the -e flag stands for, and root username, we'll say it's admin, and another variable, which is the password, will be just password. So in this way, we can actually override what the default username and password will be. So 2 more things that we need to configure in this command are container name, because we're gonna need that container name to connect with the Mongo Express. So we'll call this one MongoDB, let's say, and another one we need is the network that we created, which was called Mongo Network. So in order to make this command a little bit more structured, do it on multiple lines. So let's see. So it's more readable. So basically all these options or all these flags that we set, to go one more time through them, it's going to start in detached mode. We are opening the port on the host, username and password that we want MongoDB to use in the startup process. We're going to rewrite or override the name of the container, and this container is going to run in a Mongo network. And this should actually start the container. Okay. So if you want to see whether it was successful, we can log the container and see what's happening inside. So as we see, Mongo was started and everything actually looks good. Waiting for connections on port 27017. Okay, so now let's start Mongo Express. We want Mongo Express to connect to the running MongoDB container on startup. And here we have an example of how to run it. And here we have a list of environmental variables that we can configure. So let's quickly look at them. Username, password, we don't need them. However, we need the admin username and admin password of the MongoDB. This is actually what we overrode with admin and password. So we're going to use them because Express will need some username password to authenticate with the MongoDB and to connect it. The port is by default the correct one, so we don't need to change that. And this is an important part. This is the MongoDB server, right? So basically, this is the container name that Express will use to connect to the Docker. And because they are running in the same network, only because of that, this configuration will work. If I hadn't specified the network, then I could specify the correct name here of the container, but it wouldn't work. So with that said, let's actually create the Docker run command for Express as well. So let's clear the history and let's start. So again, we run it in a detached mode, and let's see what parameters we need. So first of all, port, let's say what is the default port that the Express runs on? That's 8081. So we'll take that. So basically it's going to run on our laptop on port 8081. The next option would be these two. And remember, environmental variables need to be specified with -e. And this is the username of MongoDB admin which is admin, because we specified it when we started the MongoDB container. This is the password. Let's set this one as well. Don't forget the network, -- net Mongo network. We have the name. We can also call it Mongo Express. And let's see what else we might need here. Yes, this is an important one. And our container name, let's actually see it again. Docker PS, the one running. It's called MongoDB. That's the container name, and this is what we need to specify here. So I'm going to write this here. And finally, the image is called Mongo Express. So I'm just going to copy this one here, and that is it. So basically, with these commands, Mongo Express should be able to connect to the MongoDB container. So let's run it. And just to make sure, let's log the container and see what's happening there. Waiting for MongoDB. Welcome to Mongo Express. It looks like it connected successfully. It says here, database connected. And the Mongo Express is available at port 8081. So let's check the Mongo Express out at the port 8081. So actually, let's close these tabs. We don't need them anymore. And here, if I say localhost 8081, I should be able to see the Mongo Express. So these are the databases that already exist by default in Mongo, or which are created on startup. And using the UI, we can create our own database. As we saw previously, we could have specified an environmental variable initDB on MongoDB startup, and that would have created a new database. However, it doesn't matter. We will just create a database name here. So we will call it user account database. So let's create one. And now we can actually use it or connect to this database from Node.js. So let's see how that works. So now we have the MongoDB container and the Mongo Express container running. So let's check that. We have both of them. We'll have to connect Node.js with the database. So the way to do it is usually to give a protocol of the database and the URI. And the URI for a MongoDB database would be localhost and the port that it's accessible at. I already went ahead and prepared the code for Node.js. So basically we're going to use a Mongo client here, which is a Node module. And using that Mongo client, we are connecting to the MongoDB database. So this is the protocol, the host, and the port that we just saw that the MongoDB is listening at, and username and password of the root user of MongoDB. Of course, usually you wouldn't put the password here or not use an admin or root username password to connect to a database, but this is for just the demonstration purposes. And these are username and password that we set as environmental variables when we created the Docker MongoDB container. So let's check that. So this is the MongoDB container command, and this is the username, root, and root password that we specified, and this is what we are going to use in the code. As I said, for demonstration purposes, I will write the password directly here. So then we connect to the database. So I also went ahead and in the Mongo Express user account database, and inside that I created a collection, which is like a table in MySQL world called users. So here I connect to a user account database and I query the collection users. And this is a GET request, so I'm just fetching something from the database, and this is update request, same thing. I connect to the database using the same URI and the database name, and I update or insert something in the collection. So now let's see how all that works. So let's head over to the UI. So in the users collection, there is no data, it's empty. So we're gonna refresh it and edit the data. So I'm gonna write here some and update it and refresh. We see that a new insert was made. So this is the update profile section here. So all this was executed, it connected to the MongoDB, and now we have one entry, which is email, coding, name that we changed. So if I'm gonna refresh it now, I fetched the newly inserted user data in the UI and I displayed it here. And also if you wanna see what the MongoDB container actually logs during this process, we can actually look at the logs. So I'm gonna say docker ps and log using the container ID. So let's say if I wanted to see just the last part of it because I wanted to see what the last activity was, I can also, let's clear this, and I can also do tail, so I can just display the last part of it. Or if I wanted, I could also stream the logs. So I'll clear this again, and I'll say stream the logs. So I won't have to do Docker logs all the time. So if I make a line here, for example, to mark the last logs, I can refresh it. Let's make some other changes. Let's change it to Jones and save profile. So I'm gonna see some activity here as well. So these connections are new, and it also says received client metadata, and this is where the Node.js request comes in with the Node.js and its version. And at the end of each communication, there is an end connection because we end the database connection at the end. So we see that also in the logs. So if, for example, something wasn't working properly, you could always check them in the logs here. So with that, I have a fully functional JavaScript Node.js application, which has a persistence in a MongoDB database, and we also have Mongo UI, both of them running in a Docker container. So this would be somehow a realistic example of how local development using Docker containers would look like. So in the last video, we created and started 2 Docker containers, MongoDB and MongoExpress. And these are the commands that we used to make it happen, right? The first, we created a network where these 2 containers can talk to each other using just the container name, and no host, port, etc. is necessary for that. And then we actually ran 2 Docker run commands with all the options and environmental variables, etc. set. Now, this way of starting containers all the time is a little bit tedious, and you don't want to execute these run commands all the time on the command line terminal, especially if you have a bunch of Docker containers to run. You probably want to automate it or just make it a little bit easier. And there's a tool that makes running multiple Docker containers with all this configuration much easier than with Docker run commands, and that is Docker Compose. If you already know Docker Compose and you were wondering why is it useful and what it actually does, then bear with me. In the next slide, I'm going to explain that. So this is a Docker run command of the MongoDB that we executed previously. So basically, with Docker Compose file, what we can do is we can take the whole command with its configuration and map it into a file so that we have a structured commands. So if you have, let's say, 10 Docker containers that you want to run for your application, and they all need to talk to each other and interact with each other, you can basically write all the run commands for each container in a structured way in the Docker Compose. And we'll see how that structure actually looks like. So on the right side in the Docker Compose example, the first 2 tags are always there, right? Version 3, that's the latest version of the Compose, Docker Compose, and then we have the services. This is where the container list goes. So the first one is MongoDB, and that maps actually to the container name, right? This is going to be a part of container name when Docker creates a container out of this configuration blueprint. The next one is actually the image, right? So we need to know which image that container is going to be built from. And of course, you can specify a version tag here next to the name. The next one is port. So we can also specify which ports is going to open. First one is on the host, and the second one after the colon is on the container. So the port mapping is there. And of course, the environmental variables can be also mapped in the Docker Compose. And this is how actually the structure of Docker Compose looks like for one specific command. Let's actually see the second container command for MongoExpress that we executed and how to map that. So now again, we have a Docker run command for MongoExpress, and let's see how we can map it into a Docker Compose. So as I said, services will list the containers that we want to create. And again, names, MongoExpress will map to the container name. The next one will be the image. Again, you can add a tag here if you want to be have a specific one. Then you have the ports, 80 to 8080. And then you have all the environmental variables, again, under the attribute environment. And this is how the Docker Compose will look like. So basically, Docker Compose is just a structured way to contain very normal common Docker commands. And of course, it's going to be easier for you to edit the file if you want to change some variables, or if you want to change the ports, or if you want to add some new options to the run command, so to say. And maybe you already noticed the network configuration is not there in the Docker Compose. So this Mongo network that we created, we don't have to do it in a Docker Compose. If we go to the next slide, because we have the same concept here, we have containers that will talk to each other using just the container name. So what Docker Compose will do is actually take care of creating a common network for these containers. So we don't have to create the network and specify in which network these containers will run in. And we're going to see that in action right away. So let's actually create a Docker Compose file. So I'm going to paste all my contents here, and this is exactly what we saw on the slides. And I'm going to save it as a Mongo YAML. And we see the highlighting as well. Be very aware of the indentation. They have to be correct. So this is the list of all the containers on the same level. And then each container has its configuration inside that. So now, compared to Docker run commands, it will be very easy for me to go here and change these environment variables or add some new configuration options, etc. So here again, for demonstration, we actually save the Docker Compose in the code. So it's part of the application code. So now that we have a Docker Compose file, the question is, how do I use it? Or how do I start the containers using that? So let's go to the command line and start Docker containers using this Docker Compose file. So the way to use it is using Docker Compose command. Now, if you've installed Docker on your laptop, it usually gets installed with the Docker Compose packaged inside. So you should have both Docker and Docker Compose commands installed as a package. So Docker Compose command takes an argument, which is the file. So I'm going to specify which file I want to execute. And in my case, it's called Mongo YAML. And at the end, I want to say what I want to do with this file. In this case, the command is up, which will start all the containers which are in the Mongo YAML. So let's actually check before that there are no containers running. So I don't have anything running here. And I'm going to start those two containers. Okay, so there are a couple of interesting things here in this output. So let's scroll all the way up. So we've talked about Docker Network and how we created our own network at the beginning to run the containers inside. And I said that Docker Compose takes care of it. And here we see the output where it actually created a network called MyAppDefault. This is the name of the network, and it's gonna run those two containers. These are actually the names of the containers that Docker Compose created. This is what we specified. And it just added prefix and suffix to it, and it created those two containers in that network. So if I actually go here and do docker network ls, I see the MyAppDefault is here. So that's one important thing. Another one is that logs of both containers actually mixed, because we're starting both at the same time. As you see, the Mongo Express has to wait for MongoDB to start because it needs to establish a connection. So we here see the logs. So MongoDB is starting. We still get connection refused because it's not started completely. And somewhere here, when MongoDB is started and listening for connections, Mongo Express is able to connect to it. So this is something that you can also do with Docker Compose. When you have two containers where one depends on another one starting, you can actually configure this waiting logic in the Docker Compose. Okay, so now let's see actually that the Docker containers are running. So we have both of them. Here you see the container names that Docker Compose gave them. And one thing here to note is that the Mongo Express actually started on port 8081 inside the container. So we can see that here. So we are opening a port 8080 on my laptop that actually forwards the request to container at port 8081. Just so that you don't get confused because it was 8080 on the slides. So now that we have restarted the containers, let's actually check the first one, which is Mongo Express. So it's running on 8080. In the previous example, we created a database and a collection, which is gone because we restarted the container. This is actually another very important concept of containers to understand. When you restart a container, everything that you configured in that container's application is gone. So data is lost, so to say. There's no data persistence in the containers itself. Of course, that is very inconvenient. You want to have some persistence, especially when you're working with a database. And there's a concept we're going to learn later called volumes. That makes it possible to have persistency between the container restarts. Okay, so let's actually create the database again because we need it. And inside the database, we had actually users collection. Let's create that one as well. And that is empty. Now let's actually start our application. And there you go. So now if I were to modify this one here, an update, I should see the updated entry here. So the connectivity with MongoDB works. So now what do I do if I want to stop those containers? Of course, I could go there and say docker stop, and I can provide all the IDs as we did previously, or with Docker Compose, it's actually easier. I can do Docker Compose, again, specify the file, and instead of up, I'm gonna say down. And that will go through all the containers and shut them all. And in addition to removing the containers or stopping them removing the containers, it also removes the network. So the next time we restart it, it's gonna recreate. So let's actually check that. Docker network ls, that default MyAppDefault network is gone. And when I do up, see, it gets recreated. That should give you a good idea of what Docker Compose is and how to use it. And then next, we're gonna build our own Docker image from our Node.js JavaScript application. So now let's consider the following scenario. You have developed an application feature, you have tested it, and now you're ready to deploy it, right? To deploy it, your application should be packaged into its own Docker container. So this means that we are gonna build a Docker image from our JavaScript Node.js backend application and prepare it to be deployed on some environment. To review this diagram that we saw at the beginning of the tutorial, so we have developed a JavaScript application, we have used the MongoDB Docker container to use it, and now it's time to commit it to the Git, right? So in this case, we're gonna simulate these steps on the local environment, but still, I'm gonna show you how these steps actually work. So after commit, you have a continuous integration that runs. So the question is, what does actually Jenkins do with this application? When it builds the application, so the JavaScript application using the npm build, etc., it packages it then in a Docker image and then pushes it into a Docker repository. So we're going to actually simulate what Jenkins does with their application and how it actually packages it into a Docker image on the local environment. So I'm going to do all this on my laptop, but it's basically the same thing that Jenkins will do. And then on later step, we can actually push the built image into a Docker repository. In order to build a Docker image from an application, we basically have to copy the contents of that application into the Docker file. It could be an artifact that we built. In our case, we just have 3 files, so we're going to copy them directly in the image and we're going to configure it. And in order to do that, we're going to use a blueprint for building images, which is called a Docker file. So let's actually see what is a Docker file and how it actually looks like. So as I mentioned, Docker file is a blueprint for creating Docker images. A syntax of a Docker file is super simple. So the first line of every Docker file is from image. So whatever image you're building, you always want to base it on another image. In our case, we have a JavaScript application with Node.js backend, so we are going to need Node inside of our container so that it can run our Node application instead of basing it on a Linux Alpine or some other lower level image, because then we would have to install Node ourselves on it. So we are taking a ready Node image. And in order to see that, let's actually go to Docker Hub and search Node here. And here you see there's a ready Node image that we can base our own image from. So here we have a lot of different tags, so we can actually use one specific one, or we can just go with the latest if we don't specify any tag. So what that actually means, basing our own image on a Node image, is that we are gonna have Node installed inside of our image. So when we start a container and we actually get a terminal of the container, we can see that Node command is available because there's Node installed there. This is what from Node actually gives us. So the next one is we can configure environmental variables inside our Docker file. Now, as you know, we have already done this using the Docker run commands or the Docker Compose. So this will be just an alternative to defining environmental variables in a Docker Compose, for example. I would say it's better to define the environmental variables externally in a Docker Compose file, because if something changes, you can actually override it. You can change the Docker Compose file and override it instead of rebuilding the image. But this is an option. So this env command basically would translate to setting the environmental variables inside of the image environment. The next one is run. So all these capital case words that you see from env and run, they're basically part of a syntax of a Docker file. So using run, basically you can execute any kind of Linux commands. So you see, make directory is a Linux command that creates a home/home/app directory. Very important to note here. This directory is gonna live inside of a container. So when I start a container from this image, the /home/app directory will be created inside of the container and not on my laptop, not on the host. So all these commands that you have in Dockerfile will apply to the container environment. None of them will be affecting my host environment or my laptop environment. So with run, basically you can execute any Linux commands that you want. So that's probably one of the most used ones. And we also have a copy command. Now you would probably ask, I can execute a copy command, a Linux copy command using run. Yes, you could, but the difference here is that, as I said, all these commands in run, for example, they get executed inside of the container. The copy command that you see here, it actually executes on the host. And you see the first parameter is dot, and the second parameter is /home/app. So source and the target. So I can copy files that I have on my host inside of that container image. Because if I were to execute run cp source destination, that command would execute inside of the Docker container. But I have the files that I want to copy on my host. And the last one, So from and cmd or command is always part of Dockerfile. What command does is basically executes an entry point Linux command. So this line with the command actually translates to node server.js. So remember here, we actually do node server.js. So we start a node server with a node.js. This is exactly what it does, but inside of the container. So once we copy our server.js and other files inside of a container, we can then execute node server.js. And we are able to do it because we are basing on the node image that already has node pre-installed. And we are going to see all this in action. So another question here, what is the difference between run and cmd? Because I could also say run node server.js. The difference, again, is that cmd is an entry point command. So you can have multiple run commands with different Linux commands, but cmd is just one. And that marks for Dockerfile that this is the command that you want to execute as an entry point. So that basically runs the server, and that's it. So now let's actually create the Dockerfile. And just like the Docker Compose file, Dockerfile is part of the application code. So I'm going to create a new file here, and I'm going to paste here the contents. So again, we're basing off node image, and actually instead of just having the latest node, I'm gonna specify a node version. So I'm going to take 13 minus Alpine. So all these that you see here are tags, so I can use any of them as a tag. So I'm gonna say 13 minus Alpine like this. So this is gonna be a specific node image that I'm gonna use as my base image. Let's actually stop here for a moment and take a little bit of a deep dive on this line. So since we saw that Dockerfile is a blueprint for any Docker image, that should actually mean that every Docker image that there is on Docker Hub should be built on its own Dockerfile, right? So if we actually go to, let's actually look at one of the latest versions, which is 13 minus Alpine, and then let's click inside. And as you see, this specific image has its own Dockerfile. And here, as you see, we have the same from that we just saw. And this is what this node official image is based off, which is a base image Alpine 3.10, right? And then we have this environmental variable set and all these Linux commands using run and some other environmental variable. And you have this entry point, which is a script. So you can also execute the whole shell script instead of separate commands. And you have this final command, right? So you don't have to understand any of this. I just want to demonstrate that every image is based off another base image, right? So in order to actually visually comprehend how this layer stacking works with images, let's consider this simplified visualization. So our own image that we're building, app with the version 1.0, is going to be based on a node image with a specific version. That's why we're going to specify from node 13 Alpine. And the node 13 Alpine image, as we saw in the Dockerfile, is based on Alpine base image with the version 3.10. That's why it specifies from Alpine 3.10. So Alpine is a lightweight base image, then we install Node on top of it, and then we install our own application on top of it. And basically this is how all the images are built. So now let's go back and complete our Dockerfile. So we have the from specified, we have the environmental variables specified, and in just a second we're gonna actually see these commands in action. So let's copy that, and this is also very important. Dockerfile has to be called exactly like that. You can't just give it any name. It is always called Dockerfile, starting with a capital D, and that's it. It's a simple text file, so just save it like this. And here you even see the highlighting and this Docker icon. So now that we have a Dockerfile ready, let's see how to actually use it. So how do we build an image out of it? So in order to build an image using a Dockerfile, we have to provide two parameters. One is we want to give our image a name and a tag, just like all the other images have. So we are going to do it using -t. So we're going to call our image my app, and we're going to give it a tag of 1.0. The tag could be anything. You can even call it actually version 1. It wouldn't matter. So we're going to do 1.0. And the second required parameter actually is a location of a Dockerfile, because we want to tell Docker, here, build an image using this Dockerfile. And in this case, because we're in the same folder as the Dockerfile, we're just going to say current directory. When we execute this, we're going to see that image is built. And this is an ID of the image that was built. Because I already have node 13 Alpine on my laptop, this just use the one I have lying around locally. For you, if it's the first time, you will actually see that it's pulling node image from the Docker Hub. So now with the Docker images, I can actually see that my image is here. It says created 2 days ago. I don't know why. But anyways, so I have the image name, which is this one here. And I have the name of the image and the tag of the image. So if we go back to this diagram that we saw in the review, so basically we've gone all these steps, or we have simulated some of the steps. We've built the JavaScript application using a Docker containers. And once the application is ready, let's say we made the commit, and we just simulated what Jenkins server also does. So what Jenkins does is actually it takes the Docker file that we create. So we have to commit the Docker file into the repository with the code, and Jenkins will then build a Docker image based on the Docker file. And what is an important point here is that usually you don't develop alone, you are in the team. So other people might want to have access to that up-to-date image of your application that you developed. It could be a tester maybe who wants to pull that image and test it locally, or you want that image to be deployed on a development server, right? And in order to do that, you have to actually share the image. So it is pushed into a Docker repository. And from there, either people can take it, for example, a tester maybe want to download the image from there and test it locally, or a development server can actually pull it from there. So let's actually just run a container. I'm just going to say docker run, the image name, obviously, and a tag like this. And in this case, I'm not going to specify any other options because we just want to see what's going on inside of the container. So I'm just going to run it. Okay, so the problem is that it can't find the server.js file, which is actually logical because we are not telling it to look in the correct directory. So since we're copying all the resources in this home/app directory, server.js is going to be there as well. And this is another topic. Whenever you adjust a Docker file, you have to rebuild an image because the old image cannot be overwritten, so to say. So what I'm going to do now is actually I'm going to delete the one that I built. So I'm gonna actually take the image. This is how you delete an image. But I can delete it because as it says, the Docker is used by a stopped container. So if I do docker ps -a, actually let's grep to my app like this. I have to first delete the container. So this is how you delete a container. It's docker rm. And once I've deleted the container, I can delete an image. So the image deletion is rmi. Like this. So if I do images now, I see my image isn't there. Okay, so we've modified the Docker file. So let's rebuild it now. So docker build again. And let's see. The image is here. So let's start it again. So it's my app 1.0. And let's run it. And as you see, the problem is fixed. App listening on port 3000. So our app is running. So this one here, my app 1.0. First of all, we can see the logs here, like this. We see that the app is listening on port 3000. We know everything is cool. To actually just get a little bit more insight, let's enter the containers, or let's get the terminal, the command line terminal of the container, and look around there. So I'm going to say docker exec interactive terminal. I'm going to specify the container ID in bash, like this. And since bin bash doesn't work, we can actually try shell. So this is something you will also encounter because some containers do not have bash installed. So we'll have to connect using bin sh. So one of them has to work always. So let's see in which directory we are. So we are in the root directory and we see our virtual file system there. And as you see, the cursor changed as well. So that means we're inside of a container. So now let's actually check some of this stuff. So first of all, we specified some environmental variables here in the Docker file. And this means that these environmental variables have to be set inside the Docker environment. So if we do env, we actually see the MongoDB username, this one here, and MongoDB password are set. And there are some other environmental variables automatically set. We don't care about that. So another thing we can check is this directory, because remember, because with this line, we actually created this /home/app directory. So let's see, /home/app. And as you can see, the directory was created. And with the next line, we copied everything in the current folder. So if we actually go and see reveal in Finder. So this is where the Docker file resides. So basically, we copied everything that is inside of this directory. So all of this into the container. Now, we don't actually need to have Dockerfile and Docker Compose and this other stuff in here, because the only thing we need are the JavaScript files, or if we build a JavaScript application artifact, just the artifact. So let's go ahead and improve that. So what I'm going to do is I'm going to create an app directory, and I'm going to copy just the files that I'm going to need for starting an application inside of a container. So I'm going to take those and the images as well. So all these are just external ones, we don't need them there, and images, the index.html file, package.json, server.js, and the node modules are inside of app. So what we can do now is, instead of copying the whole directory where the Docker file is, I just want to copy all the contents of app folder. So what I'm going to do is I'm going to say copy all the app contents. And again, because we modified a Docker file, we need to recreate the image. In order to leave the Docker container terminal, you can actually exit. So now we are on the host again. So if I do Docker images, again, I have to first delete the container and then image. But in order to delete the container, I have to first stop it. So now I can remove the container. And now I can actually remove the image that the container was based on. And let's check again. So let's actually execute that build command again. So now that we have the image built, let's actually run it. So I'm going to say my app 1.0. And of course, I could have executed with a -d in a detached mode, but it doesn't matter now. And if I do a docker ps, I see my image container running. And now let's actually enter the container again. So it. And as we learned, it was in sh. And again, we're going to see the home app. And here we just have the contents of app directory. So no unnecessary Docker file, Docker Compose, etc. files, which is actually how it's supposed to be. Or as I said, because I just had a couple of files here, I copied all of them. But usually if you have this huge application, you would want to compress them and package them into an artifact and then copy that artifact into a Docker image container. Okay, but as I said, this was just for demonstration purposes, because I just wanted to show you how you can actually start it as a container and how it actually look inside. And in this case, we improved a couple of things, but usually we would start this container from a Docker Compose as well, together with all the other Docker images that the application uses. And it also doesn't have any ports open, so this is just for demonstration purposes. So in this video, we're gonna create a private repository for Docker images on AWS ECR. There are many more options for Docker registries, among them Nexus and DigitalOcean. So we're gonna see how to create a registry there, build and tag an image so that we can push them into that repository. And in order to push the images into a private repository, you first have to log into that repository. So let's see how it all works. So the first step is to actually create a private repository for Docker. It's also called Docker registry. In this case, we're going to do it on AWS. So let's see. So I already have an account on AWS. So the service that we're going to use is called Elastic Container Registry. So ECR, Docker Container Registry. And because I don't have a repository there yet, I am presented with this screen. So in order to create a repository, click on Get Started. And here we have a repository name. And we are actually going to name it the name of the application that we have. So I'm actually going to name it my app. This is the domain of the registry from AWS. And this is the repository name, which is the same as my image name. And don't worry about the other stuff right now and just create a repository. It's as simple as that. Now, one thing I think specific to Amazon Container Service is that here you create a Docker repository per image. So you don't have a repository where you can actually push multiple images of different applications, but rather for each image you have its own repository. And you go inside of the repository, here it's empty now, but what you store in a repository are the different tags or different versions of the same image. So this is how the Amazon Container Service actually works. There are other Docker registries that work differently. For example, you create a repository and you can just throw all of your container images inside of that one repository. So I think this is more or less specific for AWS. So anyways, we have a repository which is called my app. And let's actually see how we can push the image that we have locally. So actually check that once more. So we want to push this image here into that repository. So how do we do that? If you click on this one, the view push commands will be highlighted. This is different for each registry, but basically what you need to do in order to push an image into a repository are two things. One, you have to log in into the private repository because you have to authenticate yourself. So if you're pushing from your local laptop or local environment, you have to tell that private repository, hey, I have access to it, these are my credentials. If a Docker image is built and pushed from a Jenkins server, then you have to give Jenkins credentials to log in into the repository. So Docker login is always the first step that you need to do. So here, AWS actually provides a Docker login command for AWS. So it doesn't say Docker login, but in the background it uses one. So I'm going to execute this login command for AWS Docker repository. So in the background, it uses actually Docker login to authenticate. So in order to be able to execute this, you need to have AWS command line interface and the credentials configured for it. So if you don't, I'm going to put a link to the guide of how to do that in the description. I have configured both of them so I can execute this command. And I should be logged in successfully to the Docker repository. So now I have authenticated myself to the Docker repository here. So I'm able to push the image that I have locally to that repository. But before I do that, there is one step I need to do. So I've already built my image, so that's fine. And now I have to tag my image. And if this command here looks a little bit too complicated for you or too strange, let's actually go and look at image naming concepts in Docker repositories. So this is the naming in Docker registries. This is how it works. The first part of the image name, the image full name, is the registry domain. So that is the host, port, etc. / repository or image name and the tag. Now you may be wondering, every time we were pulling an image out of Docker Hub, we actually never had this complex long name of the image, right? So when we were pulling an image, it looked like this, Docker pull Mongo 4.2. The thing is, with Docker Hub, we're actually able to pull an image with a shorthand without having to specify a registry domain. But this command here is actually a shorthand for this command. What actually gets executed in the background when we say docker pull mongo is docker pull the registry domain. So docker.io/library is a registry domain. Then you have the image name and then you have the tag. So because we were working with Docker Hub, we were able to use a shortcut, so to say. In the private registries, we can't just skip that part because there's no default configuration for it. So in our case, in AWS ECR, what we're going to do is we're going to execute docker pull the full registry domain of the repository. This is what we're going to see here, and a tag. And this is how AWS just generates the Docker registry name. That's why we see this long image name with the tag here, and we have to tag our image like this. So let's go back and take a look at our images, our image that we built again. And under the repository, it says my app. Now, the problem is we can't just push an image with this name, because when we say docker push my app, like this, Docker wouldn't know to which repository we're trying to push. By default, it will actually assume we're trying to push to Docker Hub, but it's not going to work, obviously, because we want to push it to AWS. So in order to tell Docker, you know what, I want this image to be pushed to AWS repository with the name my app, we have to tag the image. So we have to include that information in the name of the image. And that is why we have to tag the image. Tag basically means that we are renaming our image to include the repository domain or the address and the name. Okay? And AWS already gives us the command that we can execute. We want to use the specific version. So I'm going to use 1.0 in both. So what this is going to do is it's going to rename. This is what tag does. My app 1.0. This is what we have locally. This is what the name is, to this one here. So let's execute that and let's see what the outcome is. And as you see, it took the image that we had, it made a copy and renamed it into this one. So these two are identical images, they're just called in a different way. And now, when we go back, we see the docker push command. So basically this thing here is the same as docker push and name of the image and the tag. So this push command will tell Docker, you know what, I want you to take the image with tag 1.0 and push it into a repository at this address. So when I execute this command, see, the push command will actually push those layers of the Docker image one by one. This is the same thing as when we're pulling it. We also pulled the images layer by layer, and this is what happens in the reverse direction when we push it. So this is also going to take a little bit. Great, so the push command was complete, and we should be able to see that image in the AWS repository now. So if I go inside, See, I have image tag with 1.0. This is our tag here. And push the time, the digest, which is the unique hash of that image, and the image URI, which is again the name of the image using the repository address, image name or repository name in this case, and the tag. So now let's say I made some changes in the Docker file. You know, let's say I renamed this home/home/app to node app, like this. Or what could also lead to need to recreate an image is obviously when I change something in the code, right? So, you know, let's say I were to delete this line because I don't want the console log to be in my code. And now I have a different version of the application where I have changes in the application. So now I want to have those changes in the new Docker image. So now let's build a new Docker image out of it. So Docker build, let's call it my app, with a version 1.1 and a path to a Docker file. And now I have a second image, which is called my app with version 1.1. So now again, because I want to push this to a repository, I have to rename it to include the repository address inside of it. So I'm going to do docker tag. The first parameter is the image that I want to rename. And the second one is the name of that image, a new name. So it's going to be the same as the previous one because the repository name and the address is the same. Remember, we have one repository for one image, but for different versions. So we're building a version 1.1, so it should end up in the same repository. So now here we have 1.1, and if I tag that and images, I have a second image here. So I'm going to copy that, and I'm going to do docker build. And do not forget the tag, it's important because it's part of the complete name. Sorry, it's docker push. And now some of the layers that I already pushed are there. Only the ones that changed are being repushed, so to say. And also note that I just have to do docker login once at the beginning, and then I can pull and push images from this repository as many times as I want. So docker login is done once. So now that is complete. Let's actually reload this. So my repository now has 2 versions. So this is pretty practical if you are, for example, testing with different versions and you want to have a history of those image tags if you want to, for example, test a previous version. And I think in AWS, each repository has a capacity of holding up to 1,000 image versions. So for example, my app here can have 1,000 different tags of the same image. Okay. So now again, to compare it to the initial diagram that we saw for this complete flow, let's actually switch back to it quickly. So here what we did is basically simulate how Jenkins would push an image to a Docker repository. So whatever we did on our laptop will be the same commands executed on a Docker on a Jenkins server. And again, Jenkins user or Jenkins server user has to have credentials to the Docker repository to execute Docker login. Depending on the registry or repository, configuration will look different. And Jenkins needs to tag the image and then push it to the repository. And this is how it's done. And the next step, of course, we need to use that image that is lying now in the repository, and we're going to see how it's pulled from that repository. And again, we're going to do it on the local environment, but it's the same thing that a development server or any other environment will actually execute. So in this video, we're going to see how to deploy an application that we built into a Docker image. So after you package your application in a Docker image and save it in the private repository, you need to somehow deploy it on a development server or integration server or whatever other environment. And we're going to use Docker Compose to deploy that application. So let's imagine we have logged into a development server and we want to run our image that we just pushed the repository, so our my app image, and the MongoDB image, both the database and the Mongo Express, on the development server. So the my app image will be pulled from private repository of AWS, and the 2 Mongo containers will be pulled from the Docker Hub. So let's see actually how that would work. So usually, again, you have developed your application, you're done with it, and you have created your own Docker image, right? Now, in order to start an application on the development server, you would need all the containers that make up that application environment. Okay, so we have MongoDB and Mongo Express already. So what we are going to do is here we're going to add a new container in a list which is going to be our own image. So let's go ahead and copy the image from our repository. So let's actually use the 1.0. So again, remember we said that this image name is a shortcut for having a docker.io.library/mongo with like a specific version. So instead of that, because we are pulling these images from a Docker Hub, we can actually skip that repository domain in front of the images. But here, because we're pulling it from a private repository, so if we were to specify our image like this, Docker will think that our image resides on Docker Hub, so we try to pull it from Docker Hub, and of course it won't find it, because we have to tell Docker, go and look at this repository with this repository name and this tag. And of course, in order to be able to pull this image, or the Docker Compose to be able to pull this image, the environment where you're executing this Docker Compose file has to be logged into a Docker repository. So here, as the development server has to pull the image from the repository, what we would need to do on the development server is actually do a Docker login before we execute the Docker Compose. And obviously, you don't need a Docker login for Docker Hub. Those Mongo images will be pulled freely. Okay, so the next thing that we have to configure are the ports, because obviously we want to open the ports. If we go back, we see that our application runs on port 3000. So the port of the container, or where the container is listening on, is 3000. And here we can open the port on the host machine. So it's going to be 3000 mapped to 3000. We have actually the environment variables inside of the Docker file, but obviously we could have configured them in the Docker Compose, just like this. So it's an alternative. So this will be a complete Docker Compose file that will be used on the development server to deploy all the applications inside. So again, if we're trying to simulate a development server, the first step will be to do the Docker login. In this case, you have this own command for logging into the AWS repository, which I have done already in this terminal. So the next step is to have the Docker Compose file available on this development server, because we have to execute the Docker Compose file. Because we're simulating here, the way I would do it is I'm going to create a Mongo YAML file in the current directory where I am. I'm going to copy this and save. So now I have my Mongo YAML file, and now we can start all three containers using Docker Compose command. -f up. And here we see that app started on 3000 and MongoDB and Express started as well. So let's check again now. And here we saw the database is lost every time we recreate a container. And of course, that's not good. And we're going to learn how to preserve the database data when the container restarts using Docker volumes in the later tutorials, because this is not an ideal state. Okay, so now that we have a database and a collection, let's actually refresh, and our application works as well. Let's check. Awesome. So our application works. Let's refresh this one as well. And there is actually one thing that I needed to change in the code to connect Node.js with MongoDB. So let's actually go and look at that. These are my handlers in Node.js where I connect to the MongoDB database. So the URIs are the same. And what I changed here is that it was a local host before. So instead of local host, I changed it to MongoDB, because this actually is a name of the container or of the service that we specify here. So this actually leads back to the Docker network, and how Docker Compose takes care of it is that in the URI, or when I connect one application in a Docker container with another one in another Docker container, I don't have to use this local host anymore. Actually, I wouldn't even need to use the port even, because I have all that information, so the host name and the port number, in that configuration. So my application will be able to connect to MongoDB using the service name. And because of that, you don't have to specify here a local host and the port number, which is actually even more advantage when you consider using Docker containers to run all of your applications, because it makes the connectivity between them even more easier. And that actually concludes this diagram that we saw previously. We have gone through all of the steps where we saw how to develop a JavaScript application locally with Docker containers. Then we saw how to build them into an image. just like a continuous integration build will do it. Then we pushed it into a private repository and we simulated a development server where we pulled the image from private repository and the other images from the Docker Hub, where we started the whole application setup with our own application and the 2 Mongo applications using a Docker Compose, which is how you would deploy an application on a dev server. So that now testers or other developers will be able to access the development server and actually try out the application that you just deployed. Or you can also use it for demos. So in this video, we're going to learn about Docker volumes. In a nutshell, Docker volumes are used for data persistence in Docker. So for example, if you have databases or other stateful applications, you would want to use Docker volumes for that. So what are the specific use cases when you need Docker volumes? So a container runs on a host. Let's say we have a database container, and a container has a virtual file system where the data is usually stored. But here there's no persistence. So if I were to remove the container or stop it and restart the container, then the data in this virtual file system is gone and it starts from a fresh state, which is obviously not very practical because I want to save the changes that my application is making in the database. And that's where I need Docker volumes. So what are the Docker volumes exactly? So on a host, we have a physical file system, right? And the way volumes work is that we plug the physical file system path. It could be a folder, a directory, and we plug it into the container's file system path. So in simple terms, a directory, a folder on a host file system is mounted into a directory or folder in the virtual file system of Docker. So what happens is that when a container writes to its file system, it gets replicated or automatically written on the host file system directory and vice versa. So if I were to change something on the host file system, it automatically appears in the container as well. So that's why when a container restarts, even if it starts from a fresh state, in its own virtual file system, it gets the data automatically from the host because the data is still there. And that's how data is populated on the startup of a container every time you restart. Now, there are different types of Docker volumes, and so different ways of creating them. Usually the way to create Docker volumes is using Docker run command. So in the Docker run, there is an option called -v, and this is where we define the connection or the reference between the host directory and the container directory. And this type of volume definition is called a host volume. And the main characteristic of this one is that you decide where on the host file system that reference is made. So which folder on the host file system you mount into the container. So the second type is where you create a volume just by referencing the container directory. So you don't specify which directory on the host should be mounted, but that's taking care of the Docker itself. So that directory is, first of all, automatically created by Docker under the var lib docker volumes. So for each container, there will be a folder generated that gets mounted automatically to the container. And this type of volumes are called anonymous volumes because you don't have a reference to this automatically generated folder. Basically, you just have to know the path. And the third volume type is actually an improvement of the anonymous volumes, and it specifies the name of the folder on the host file system. And the name is up to you. It's just to reference the directory. And that type of volumes are called named volumes. So in this case, compared to anonymous volumes, you can actually reference that volume just by name. So you don't have to know exactly the path. So from these 3 types, the mostly used one and the one that you should be using in production is actually the named volumes, because there are additional benefits to letting Docker actually manage those volume directories on the host. Now, this showed how to create Docker volumes using Docker run commands. But if you're using Docker Compose, it's actually the same. So this actually shows how to use volume definitions in a Docker Compose. And this is pretty much the same as in Docker run commands. So we have volumes, attribute, and underneath you define your volume definition, just like you would in this -v option. And here we use a named volume. So db-data will be the name, reference name that you can just think of. It could be anything. And in var lib MySQL data is the path in the container. Then you may have some other containers. And at the end, so on the same level as the services, you would actually list all the volumes that you have defined. You define a list of volumes that you want to mount into the containers. So if you were to create volumes for different containers, you would list them all here. And on the container level, then you actually define under which path that specific volume can be mounted. And the benefit of that is that you can actually mount a reference of the same folder on a host to more than one containers. And that would be beneficial if those containers need to share the data. In this case, you would mount the same volume name or reference to 2 different containers, and you can mount them into different paths inside of the container even. In this video, we are going to look at Docker volumes in practice, and this is a simple Node.js MongoDB application that we're going to attach the volume to so that we don't lose the database data every time we restart the MongoDB container. So let's head over to the console, and I'm going to start the MongoDB with the Docker Compose. So this is how the Docker Compose looks like. We're going to start the MongoDB container and the Mongo Express container so that we have a UI to it. So I'm going to execute the Docker Compose, which is going to start MongoDB and the Mongo Express. So when it started, I'm going to check that Mongo Express is running on port 8080. And here we see just the default databases. So these are just created by default on startup. And we're going to create our own one for the Node.js application. And inside of that database, I'm going to create users collection. So these are the prerequisites, or these are the things that my Node.js application needs. So this one here, in order to connect to the database MyDB, this is what we just created, MyDB, and inside of that to the collection called users. So let's start the application, which is running on port 3000. So here, and this is our app, which when I edit something here, will write the changes to my database. Now, if I were to restart now the MongoDB container, I would lose all this data. So because of that, we're going to use named volumes inside of the Docker Compose file to persist all this data in the MongoDB. So let's head over to Docker Compose. So the first step is to define what volumes I'm going to be using in any of my containers. And I'm going to do that on the services level. So here, I define the list of all the volumes that I'm going to need in any of my containers. And since we need data persistence for MongoDB, we're going to create a Mongo data volume here. Now, this is going to be the name of the volume reference, but we also need to provide here a driver, local. So the actual storage path that we're going to see later once it's created, is actually created by Docker itself. And this is a kind of an additional information for Docker to create that physical storage on a local file system. So once we have a name reference to the volume defined, we can actually use it in the container. So here, I'm going to say volumes. And here I'll define a mapping between the Mongo data volume that we have on our host. And the second one will be the path inside of the MongoDB container. It has to be the path where MongoDB explicitly persists its data. So for example, if you check it out online, you see that the default path where MongoDB stores its data is data/data/db. And we can actually check that out. So if I say docker ps and go inside the container, it's -it. I can actually see data db, and here is all the data that MongoDB actually holds. But this is, of course, only the container. So when the container restarts, the data get regenerated. So nothing persists here. So this is the path inside of the container, not on my host, that we need to reference in the volumes here. So we're attaching our volume on the host to data/data/db inside of a container. So for example, for MySQL, it's going to be var lib MySQL. For Postgres, it's also going to be var lib PostgreSQL /data. So each database will have its own, so you'd have to actually find the right one. So what this means is that all the data that we just saw here, all of this will be replicated on a container startup on our host, on this persistent volume that we defined here, and vice versa. Meaning when a container restarts, all the data that is here will be replicated inside of that directory inside of a container. So now that we have defined that, let's actually restart the Docker Compose and restart it. So once we create the data, and I'm going to use the collection, and let's actually change this one. Let's travel here and update it. So we have the data here. So now that we have the persistent volume defined, if I were to restart all these containers, this data should be persisted. So on the next restart, I should see the database, MyDB collection, and the entry here. So let's do that. I'm going to do down. Great. So let's check. See, the database is here, the collection is here, and the entry has persisted. So now let's actually see where the Docker volumes are located. on our local machine. And that actually differs between the operating systems. For example, on a Windows laptop or a computer, the path of the Docker volume will be at program data docker/volumes. The program data Docker folder actually contains all the other container information. So you would see other folders in this Docker directory besides the volumes. On Linux, the path is actually /var lib docker volumes, which is comparable to the Windows path. So this is where the Docker saves all this configuration and the data. And on the Mac, it's also the same one. Inside of this volumes directory, you actually have a list of all the volumes that one or many containers are using, and each volume has its own hash, which has to be unique. And then /_data will actually contain all the files and all the data that is persisted. Let's head over to the command line and actually see the volumes that we persisted for MongoDB. Now, an interesting note here is that if I were to go to this path that I just showed you in the presentation, which is var lib docker, see, there is no such a directory, so that could be a little bit confusing. But the way it works on Mac, specifically on Linux, you would actually have that path directly on your host. But on Mac, it's a little bit different. So basically what happens is that Docker for Mac application seems to actually create a Linux VM in the background and store all the Docker information or Docker data about the containers and the volumes, etc. inside of that VM's storage. So if we execute this command here, so this is actually the physical storage on my laptop that I have where all the data is stored. But if I execute this command, I actually get the terminal of that VM. And inside here, if I look, I have a different virtual file system. And I can find that path that I showed you here. So it's var lib docker. See, so I have all this Docker information here. I have the containers folder and I have volumes folder. So this is the one we need. So that actually go to the volumes. And this is a list of volumes that I have created. And this is the one that came from our Docker Compose, right? This is the name of our app. This is what Docker Compose actually takes as the name. We can actually take a look here. So when it's creating these containers, it appends this name as a prefix, and then there is MongoDB. And our volume has the same pattern. It has the prefix, and then MongoData, this is the name that we defined here. So now, if we look inside of that MongoData volume directory, we see that _data. This would be the anonymous volumes. So basically here you don't have a name reference, it's just some random unique ID. But it's the same kind of directory as this one here. The difference being that this one has a name. So it's easier to reference it with a name. So this is anonymous volume, this is a named volume. But the contents will be used in the same way. So here, as you see in this _data, we have all the data that MongoDB uses. So this will be where it gets the default databases and the changes that we make through our application inside. And if I go inside of the container, so remember, this volume is attached to MongoDB and is replicated inside of the container under path /data/db. So if we go inside of the container, actually leave it here, PS, /db, we'll see actually the same kind of data here. So we have all this index and collection files, just like we did in this one. So now whenever we make changes to our application, for example, we change it to Smith, whatever, and this will make the container update its data, and that will cascade into this volumes directory that we have here. So that on the next startup of a container, when the /data/db is totally empty, it will actually populate this directory with the data from this persistent volume, so that we will see all the data that we created throughout